Hello everybody, in this video, we are going to see how to use the ADXL345 accelerometer sensor with the ASP32 using the NUT-XR TOS. We have two applications. One is used to read the XYZ axis data from the accelerometer, and another one is used to detect the single tap and double tap. First, we will see the XYZ axis data reading application. This ATX I2C write function writes the 1 byte data to the accelerometer registers using the I2C communication. This ATX I2C read function reads the multiple byte data from the accelerometer registers using the I2C communication. This ATX ADXL345 init function initializes the accelerometer. Initially, we are resetting the power and reading the device ID. If the device ID matches, then we are making the accelerometer into the measurement mode. At last, we are disabling the interrupts. This is the task function that we have created. First, we are opening the I2C driver. Followed by that, we initialize the accelerometer. Then we read the X, Y, Z axis data from the accelerometer registers. Finally, we convert the values based on the gravity force and then printing it. This will read the data continuously until any I2C read error happens. Main function just creates the task and it executing the task that creates. This header file has all accelerometer registers and other macros that we have used in the source code. This is our next application, which detects the single tap and double tap. These ATX I2C write function, ATX I2C read function, ATX ADXL345 init functions are same as the previous application. ATX ADXL345 single double tap enable function enables the single tap and double tap functionalities. In the first step, we are enabling the tap detection in the XYZ axis. Then setting the tap threshold to 16 mg, by giving the value of 255. The one increment in value adds 62.5 mg. After that, the duration is set to 150 ms. Then, latency is set to 175 milliseconds. And the window is set to approximately 318 ms. So these configuration values are set to the respective registers. Finally, we are enabling the single tap interrupt and double tap interrupt. This is the task function that we have created. First, we are opening the I2C driver. Followed by that, we initialize the accelerometer. Then we enable the single tap and double tap feature. After the configuration, we are reading the interrupt source register and checking the appropriate bit. If the fifth bit has set, then double tap has been detected. If the sixth bit has been set, then the single tap has detected. Main function just creates the task and it executing the task that creates. We have gone through the two applications. Let's build the NUT-X. Make sure that you are connecting the SCL and SDA line correctly. Let's enable the I2C one in the menu config. Enable the I2C device driver. Enable the float in printf. Enable the accelerometer applications that we have added now. We have enabled all the required things. Let's save this changes and exit the menu config. Let's test the first application. That have to read the X, Y, Z axis data from the accelerometer. Hoo-hoo, it is working as expected. It's a time to test the next application, which detects single and double tap. I have given the link in the description, that has the source code and explanations. Thanks for watching.